Hello friends, in this video I'd like to solve the following problem from the Vietnamese Mathematical Olympiad 1987, problem number 5. Let f be a function defined on the set of non-negative numbers into the set of real numbers, and let it be a differentiable function. Suppose furthermore that absolute value of f of x is less than or equal 5, and f of x times f prime of x, its derivative in other words, is greater than or equal sine of x for all non-negative numbers x. The question is, does limit as x goes to infinity of f of x, does it exist? Well, so here are my hints for this problem. Remember this well-known fact from mathematical analysis that every weakly increasing function on Nondecreasing, if you will, every weakly increasing function, g, bounded from above, has a finite limit as x goes to infinity. Then try looking at mapping which maps x to f of x squared plus 2 times cosine of squared. It's really the key here. And then remember also that if limit as x goes to infinity of g of x exists, but limit as x goes to infinity of h of x does not exist, then limit as x goes to infinity of g of x plus h of x also does not exist. So give this problem a try and I will see you in a moment. Okay, so here is my attempt. So first of all, let's consider g of x, which is defined as f of x squared plus 2 times cosine of x. Let's consider this function. Well, since f is differentiable, g of x is also differentiable. And we have the following: g prime of x equals, well, using the chain rule, it's 2 times f prime of x, f of x, derivative of cosine is minus sine. And let's notice that by our second condition, which I will mark double asterisk, this is necessarily greater than or equal 0 by our condition double asterisk, which means that, maybe let's write it in pink, g is weakly increasing or non-decreasing if you prefer this terminology, and that in turn means that nothing yet. So let's stop at that. And now I wish to show that this function is bounded from above, to show that this function g has a finite limit. How can I do it? Well, let's take a look. By my first assumption, by my first condition, which I will mark single asterisk, f of h, absolute value of f of h, is less than or equal 5. So it's by asterisk. Well, I can take both sides and square them. So I have f of x squared is less than or equal 25. And then what can I do? Well, f of x squared, I will subtract from both sides, or maybe first I will add to both sides 2 times cosine of x, and it's less than or equal, of course, 25 plus 2 times cosine of x. But we know that cosine is bounded by 1 from above, from its less than or equal 27. Okay. So now we know, and let's also take notice that this function is just g of h. So g of h is less than or equal 27. And you know what? I will mark this condition triangle, and I will mark this condition square. Why not? By these two conditions, so by my condition triangle and my second condition square, I know that my function has a finite limit. So this limit of my function g of h exists and is finite. It exists and it is finite. Very well. And now let's see. Let's see. Well, since this limit exists, and since limit as x goes to infinity of minus 2 times cosine of x doesn't exist, we know that. Well, since this doesn't exist, also limit as x goes to infinity of g of x minus 2 times cosine of x also does not exist. But let's take a look. What is g of x minus 2 times cosine of x? Well, it's just f of x squared, i.e. limit as x goes to infinity of f of x squared does not exist. Well, if this does not exist, then in turn limit of just f of x cannot exist as well, because if it were to exist, then its square would also exist. So that implies that limit as x goes to plus infinity of f of x does not exist. Does not exist, sadly. Okay, very well. And that is our answer. Our limit does not exist. So the answer is no. No. Okay, so I hope that you've learned something new this time. Thank you for watching, and I will see you next time. Goodbye.